Right.
So, session 6. Today we are going to be talking about higher order functions. So, higher order functions are functions that operate on other functions, either by taking them as arguments or by returning them. So we have used higher order functions before, where a function will return the result of another function. So here we have a simple function that takes two numbers and adds them together, and then returns that result so that it might be used outside of that function. Similarly, here we have a function that multiplies two numbers and returns their answers. Here I have a third function called arithmetic, or arithmetic. It takes two numbers, and the third argument is a function itself. We didn't call the function with the parentheses, but we passed the name of the function itself, that it might be called within this function. So that's how you can take a function as an argument and then call it with the name that that parameter has taken with our arguments as needed and return that answer. So an example of how I could use arithmetic is I could give it two numbers on which to operate and then the name of the function that I want it to use. So this would, in place, calc is now the add function, and it's going to add 2 and 3. This returns 3 plus 2, which is 5, which then gets stored in this answer and is returned by this function right here. Right. So why would we want to do this? There are many cases where passing functions can drastically reduce the complexity of our programs. Many cases where, let's say, we have a list of operations and functions that we want to apply them to. Instead of just storing an array of functions to pass and call, we could just pass it as an argument to an existing overarching function. Are there any questions on what higher order functions are? No? All right. I also have a session example set up talking about a kind of syntax you'll see in JavaScript called destructuring. Now, this is less critical to your understanding of programming and fundamentals of JavaScript and thinking critically, but it is a notation you're going to see a lot, especially in React. So I think you should at the very least be familiar with it, and I might use it in some of my solutions in these later exercises. All right, so the destructuring assignment, and I found a lot of these examples from the Mozilla documentation itself and just modified it slightly. They do a really wonderful job of explaining a lot of JavaScript materials. And if you want to learn about this in detail, I would strongly recommend you go to their documentation page, where they can tell you all about, no, not that. They can tell you all about destructuring assignments in more complex examples. So here, the destructuring assignment, much like our equal sign assignment operator, is used to assign values to variables, but it can do so to multiple variables at the same time. So let's say I had an array of two values, 10 and 20, and I want to assign 10 to A and 20 to B. I can do so by, on the left-hand side of the assignment operator, placing these variables that are presently undefined inside of brackets, as though it was an array itself. So this assigns 10 to A and 20 to B. And let me just comment the rest of this out so we can look at the outputs one at a time. You see here that it does in fact return 10 for A and 20 for B. Now, destructuring can also be used with our existing knowledge of spreading. So let's say I create a variable rest, which is going to store an array. Here I can pass A, B, and a spread on the rest variable. And what that's going to do is assign 4 to A, 5 to B, and take everything else in the array and put it inside of rest. Now, if I didn't spread it, this would be treated like just any other variable and would store 6 and would ignore the rest of the array. So if I run this, you'll see we got 4 and 5 for A, and everything else that was passed goes in to rest. And like I said, if we don't pass a spread and we give it more values to assign than are given, it just ignores everything else after it. So here, A is going to be 9, B is going to be 8, and everything else after it is just ignored. All right. Do we have any questions at this point? No? All right. There are a couple other cool features about destructuring, is that if a value is not provided, I can specify a default value for any of these. So for example, here, I can say I want to assign the following onto our variables A, B, and C. And I didn't declare C, I probably should have, but it will run anyways. So what this does is it assigns 2 to A. So even though I said A equals 1, that value of 1 is overridden by the value of 2 I've just provided. I have no other values to assign, so B, which doesn't have a default value, is going to be undefined. And C, which does have a default value, is going to stay 7. So these values should be 2, undefined, and 7 respectively. And if I run this, I will see that is the case. If I did not give 2, then A is going to be 1. Similarly, we can ignore values by leaving a position on the left-hand side empty. So here we have A. We could have placed another variable here, but elected not to. So that's having 2 commas next to each other. And then we place another variable in our last position. So 1 goes to A, 2 goes to nothing, it's ignored, and 3 goes to B. So this will make A 1 and B 3. And that's what we see. And lastly, we can destructure objects in the same way that we destructure arrays, but with one key difference. We cannot assign to variables that have already been declared. So when creating assignments here, we have to give it its assignment, like we have to declare it for the first time here. So here you see I have A and B, and I've been overriding A and B. Here, I have 2 variables, foo and bar, which I want to set, and those are constants. Like I could redo it again. Let's see, if I go here with A and I want to use A and B, if I were to change this to A, it's going to complain that A is already defined. Yeah, A has already been declared, sorry. But foo and bar, new ones which I've never let or made in the first place, runs just fine. So what this does is I have a dictionary, P is 42 and Q is true. And here I'm saying look up the value of P and assign that to foo. Look up the value of Q and assign that to bar. And the cool thing about this is if I change the order, it doesn't matter, because unlike an array where it checks the order in which these things are provided due to the assignments, here it just checks for the label associated with it. So now I still have 42 and true. Do we have any questions about destructuring? No? All right, so you may see me use destructuring in some future examples. I did say that we are going to go over the prime numbers example from yesterday, but before I do that, I think we should go over a warm-up exercise to get our juices flowing. So let's go to, can I go to the bar control flow? All right, so this one, write a function that takes in a number and it represents your age, and it returns true or false depending on whether or not you are eligible to go to a bar. So at least in the United States, you need to be at least 21 years of age. So if you're over 21, at least 21, it will say true, otherwise it will say false. And again, you don't need an if-else statement. I know it says control flow, but control flow does not necessarily mean you have to use if and else. So I've noticed some of you have been doing that where you return Booleans. I want to challenge you to just do a single line to return it without using if and else. All right, so I'm going to put this in the chat. There we are. And I'm going to put 10 minutes on the clock. online stopwatch. All right, and I will see you then. All right. So the problem, can I go to the bar? We have two tests here. I can just copy them. Always good to write tests, no matter how simple the problem is, no matter how complex the problem is. You always want to check that your results are in fact working. Because sometimes it might be a simple thing like, oh, I forgot to replace this greater than equal sign with a greater than sign, or something silly like that, and it gets the best of us. So always write tests. Oh, it's not what I was trying to do. I want to select this. Copy. Yeah, and you don't have to say equals true ever. You can just say it itself. And if you want it to equal false, you can just, put the negation of it in front. Oh. Sorry, it's a little slow again. Don't know why it's like this sometimes, but why did it do that? All right, so can you enter the bar or not? So if you are your age, if it is greater than or equal to 21, then you can enter the bar. So if I run this, I should see that both returns true. Yeah, so like I said, very important you don't forget that little equal thing, otherwise a 21-year-old wouldn't be able to enter. Are there any questions about this particular problem? No? If there aren't any, I'll delete these and move on to our review problem of prime numbers. So we've already attempted this problem before, so I'm just going to go over the solutions to it. So there were two solutions. One was using built-in methods and one was using for loops. We did the one with built-in methods last time. Let's go down over here. So to see if something is prime, we can do this with for loops. The first thing we can do is, well, we have the number in question, and we can go over all the numbers before it, starting from 2 up to, but not including the number. So I can say for, let's see, I have a number, let I equal 2, because we're starting from 2. I is less than the number, but not equal to, because a number will always divide itself. And we want to increment by 1, because we want to check all the numbers between 2 and the number not inclusive. Here I can say, if it is the case that our number, when divided by I, returns no remainder. It has no remainder because it divides it perfectly. Then I can simply return false. It can't be prime because something divided it. Return false. And function bodies are not necessary for one-line solutions. Same for this for loop. I didn't really need this, but it's generally, most people would agree that it's nice to have them in case you want to add something else to it. And if I manage to go through all of them and I didn't find any, then I know that it is in fact a prime number, and I'll simply return true. And I did require this if statement. I know earlier I was talking about having or not having the if statement. I require it because I need to check all the values within it. But if there's an else situation, I'm not going to return true. I'm just going to return nothing and keep on iterating over the for loop, because when you return, it stops the for loop where it is and just returns the value. All right, so let's take these tests right here, 3, 5, and 10. Put them down here. Change this to say, well, I don't need this at all, actually. So I can get rid of the ends. Take this last one and take this negation. I'm going to console.log the results. And I don't know what that extra exclamation mark's doing in there, but there we go. And if I run this, I should see that they're all true. Yep. Are there any questions about this particular problem?
I kind of did it differently. I was wondering if you could like look at it.
Sure, yeah. Do you want to post it in the chat, or do you want to send me a link or something? Or?
No, I'll post it in chat.
Okay, sounds good. So function is prime. If the number is divisible by 2, return true, else return false. That only works for, well, here's the thing, that checks if a number is even, but even is not the same thing as prime, right? So, I mean, all numbers that are even won't be prime. This is true. However, there are other numbers that are odd that are prime. Like take the number 7, for example. 7 is a prime number, but it's odd, right? And if I look at another number like 3, 5, 7, 13, so some odd numbers are non-prime, like 9. 9 is an odd number and it isn't prime. So checking if something is even or odd won't tell you if the number is prime. You have to check all the values before that number and see if any of them divide it, not just 2.
Okay.
All right. All right. By the way, there are many algorithms to check if a number is prime. This is not the most efficient algorithm. There are way better ones, but they are very complex and very mathematically inclined. But you can feel free to look into them. Would you check for 1 or 2 also? That's an interesting question. Is 1 prime? Well, the definition of prime is that it's not divisible by 1 or itself. It's divisible by any numbers before it, except for 1 in itself. There's no numbers before 1 that can divide it except for 1 in itself. So you could argue that it is prime by default. Like if I was to run this, if I put 1 in here, it just wouldn't run because, you know, is 2 less than 1? No, it isn't. So it's immediately going to return true. And is 2 a prime number? Well, divisible by 1 and itself is the exception. The only number here is 1 and 2. And we can't look at 1 and 2. Well, we can't look at 2 either because that is the number itself. So naturally, that number would be prime as well. And that's actually a very good question. Is 1 or 2 prime? Look it up. My understanding is that they should be prime. Some people say that it isn't a prime number. This guy claims that it isn't a prime number. The number 1 is not prime. See, based on the definition we've been operating on, it's fair to assume that 1 is prime. And here's a definition. An integer greater than 1 is called prime if its only positive divisors are 1 and itself. So if we only go with this definition, all of its positive divisors, excluding 1 and itself, are prime, then this would include 1. But this definition saying an integer greater than 1 excludes 1, but should include 2. So here's the thing, is 2 prime? So I guess it depends on your definition of prime. When I grew up, I was under the understanding that 1 is in fact a prime number. So 2 is a prime number because it is in fact greater than 1. And if I were to look at this and console log is prime 2, and I can do it for 1 as well. 2 and 1. We get that 1 is prime and 2 is prime. And if you believe that 1 is non-prime, depending on your definition, I guess you could just add an edge case really here and saying if the number is 1, then I can return false. Because that one exception breaks our rule. And because it's expected to be false we can see that the negation of it and see that all of our tests passed. All right, so that was actually a really good question. More of a math question on what it means to be prime, but yeah, I think that's good. So the definition that I've encountered is a positive integer greater than 1. Would it matter if you use the strictly equal versus non-strictly equals comparison? That here's the thing, I'm expecting to receive numbers only. If they gave me a string one, I think that it would still work if I gave it a string number, right? But so no, in this case, it doesn't matter. It matters when I'm looking for a specific thing where I care about types, but here that isn't the case. So if I say is 5 prime and I give it 5 as a string and I run it, you'll see that, yeah, it is prime, because you can do comparisons between strings and numbers and it will work exactly the same. And I can increment this integer just as I would normally. And that would also pass this test if I made 1 a string as well. This will also pass true. Right. So the benefit of using non-strictly equal is that I can pass numbers as strings as well, but that's not a requirement. So you could have used strictly equals and it would have been just as valid. So in this situation, it doesn't matter. Are there any other questions about prime numbers? No? All right. Does anyone want me to review the built-in methods variant of this problem, or is it sufficient as I've explained it previously? Nope. I'm going to assume that's a no and move on to the next exercise. All right. So this problem is called high score. High score arrays and loops. Let's close these tabs. All right. Write a method that takes an integer array of student scores and returns the highest test score. So here I have a bunch of scores and I want to see the high score, which is 92 here. What's the biggest number in this array? That's going to be 97. Any questions about this problem? Any clarifications you'd like? If there aren't any, I will send this in the chat and put 15 minutes on the clock. All right, to recap what I just said, there are 2 solutions to this problem, one using for loops and one without. The first of which is to take the array and spread it to the existing math.max function, which will find the largest value of the array. The second is for us to do it using a for loop. And the assumption is you start with 0, knowing that all test scores are going to be at least 0. And then I check at each single score, is it bigger than the current value I have stored as a high score? If it is, then I update my high score. And if it isn't, then I ignore it and I move on to the next value. And after going over all the scores, I will have got the largest score. And I can show that by console logging the comparison at each instance of the for loop. First, we assume that the high score is 0. We update it to 89 because that's the first value. At the next instance, we ignore 76, so it's less than 89. I keep going until I find one that is in fact greater, and that updates the high score. And after I've gone through all of them, I'll have found the largest value, which in this instance is 92. The second instance, it found 97. And that's how the for loop approach to the high score problem works. All right. So the next problem we have is sum of the negatives. All right. So what we need to do is write a method which takes an array of integers and returns the sum of only the negative integers in the array. So let's look at the first example here, 3, -1, -9, and 2. What I'm saying is I want to ignore all the values that aren't negative, and of the negative values, being these two right here, I want to add them up. -1 plus -9 is -10. Here, there aren't any negative numbers, so it's going to return 0. Any questions as to what this problem is asking us? No? All right, I'm going to put this in the chat. And I'm going to put 15 minutes on the clock. All right. So I'm just going to copy these to make our test case. All right, so the first one we can do is we need to filter out all of the non-negative values. That means all values that are greater than or equal to 0 need to be ignored. Well, actually, even if I considered 0, it wouldn't have impacted the result, because if I add 0 to something, it's the same value. So I could just say all values greater than 0, and both would be equally valid in this case. So let's say I want to return, and I'm going to take the number array, and I want to filter it on the condition that some number is going to be less than 0. And that's going to give me all the negative values. And actually, I'm going to do this in a console so we can see the results one step at a time. So I'm going to call my num array equal to this array right here, 3, -1, -9, and 2. And now I want to filter that array on the condition that each number is less than 0. And that leaves me with -1 and -9, because those are the only numbers that are less than 0 and are therefore negative. Now I can sum these values using the same math dot, no, there is no math dot sum, sorry, but there is something called reduce. And reductions are designed to take collections of numbers and do operations on them, resulting in exactly one number. So I could add all the numbers, I could multiply all the numbers, I could square each number and then add it up. I've used numbers, I've used reduce before, I'm pretty sure. If I haven't, I can show you the documentation real quick. So reduce documentation at MDN. So the array prototype reduction. What this, a reducer takes a function called a callback function, and it has two arguments. One is the accumulator, or the sum. It collects the values as it goes through the array. And one is the current value on which to do an operation. This would sum over all the values in the array. So it takes the current accumulator, let's say it's at 0, and it takes the current value 1 and it adds it to it. Then it moves on to the next value, 2, add that to 1, now I have 3. 3, add it to 3, now I have 6. 4, add it to 6, now I have 10. And that's the sum over everything in the array. I could have multiplied it, I could have squared each of these values or passed it through another function to get a different value. So reducers are a lot more powerful than a generic sum method, in that there's a lot more things we can do with them. And unfortunately, there is no sum method in JavaScript as far as I can find. So after I filtered it, I can say I want to reduce it. And they make a separate line for the reducer. Not necessary, unless you're going to be reusing it, or if just to make your code look cleaner. That's a matter of personal preference. I like to abbreviate accumulator as ACK and the current number as per, but you can call them whatever you want. So I want to take the accumulator and add to it the current value, and that should allow me to sum over all the values in here, which is -1 and -9, and that gets me -10. So I can have my number array, and I filter it, and then I reduce, if I can spell reduce, that is, reduce with an accumulator and a current value. And I return the accumulator plus the current value. All right. And if I run this, I should see that they both return true. Oh, there's one other thing I must mention. Sometimes you have to specify, you should specify the default value of the reduction on what to do. So here, there's no negative values. So this filter returns an empty array. And if I try to reduce on an empty array, it's gonna complain there's nothing to take. So the initial value of the accumulator is set to the first value in the array. And then it just does subsequent operations on the next ones. So if the array is empty, it doesn't have anything to work on. So I can provide a default value as the second parameter as the second argument, sorry, to the reduce method. If I run this, I see they both return true. So that is the filter and reduction approach to summing negatives. Are there any questions to this particular approach? No? All right. So now we can move on to the for loop approach. One thing we can do is we can have a for loop over the array, check if a number is in fact less than 0. And if it is, I can add it to some sum. So I'm going to say let the sum equal 0. I want to have a for of loop, so I can say for let num of our num array. So that means I'm getting each number in the array. And now I want to say if that number is less than 0, which means it's negative, then I want to add it to our sum. So sum plus equals that number. Actually, I could probably do this in one line because it's a one-line if statement, and that's, again, a matter of preference. You don't need these braces here. And after we've gone through all of them, I can return the sum. And if I run this, I see they both return true. Are there any questions? No? All right. Moving on to the next problem. Actually, yeah. Now is a good time to take a break. Let's take a 10-minute break before we move on to the next problem. I'm going to put 10 minutes on the clock and take this time to stretch, walk around the house, go to the bathroom, drink some water. I will see you in 10 minutes. I'm just going to erase this. Moving on to our next problem, the 2 strikes problem. All right, 2 strikes, arrays and loops. So we need to make a method that takes in a array of strings, each of which represents a license plate number. The method should be to return a string array of any plate numbers that appeared at least twice. And if none of the plate numbers appeared more than once, you should just return an empty array. So here you see here, 34B 317 appears here, the second and the last element, and therefore it is returned in our string array. Here we don't have any that are the same, and therefore we return nothing. Also, do be careful to check for instances of if there are, let's say, more than 2, if there's 3, if there's 4, it should still only return one instance of it in our final result to indicate that there are at least 2 of it. All right. Are there any questions as to what this problem is asking us? No? All right. Then I will send this in the chat. And I will see you in 15 minutes. All right. So there are two solutions to this problem, one with built-in methods and one with loops. I'm going to take both of these to make some test cases and head to our index.js. All right. So I need to format this so that JavaScript can work with it. Oh, one other thing. You can't compare arrays. So I'm just going to look at the outcome here and verify that this should be an empty array. And this should be just this string. I'm actually going to add an additional test because I want cases for when there are more than 2 instances of something in the array. And you'll see why that's important later. So let's make a simple kind of test here. If I had 1, 2, 3, 2, and 2. I know those aren't exactly strings, but the logic will work the same regardless, at least in my implementation. Don't worry about this in your test. This is just for my sake. All right. And the expected output for here, by the way, should just be an array with 2 in it. But on some implementations, if you're not thinking carefully, you might end up seeing 2 and 2. So one thing I can do is I can make a function that checks for the counts of something within an array. And here it will take a thing to check for. So here I can say it's going to take a plate and it's going to operate on plates. It's going to check for a plate in plates in particular. So here I can say, well, I'm going to look at plate this, and I'm going to map on each one whether or not it equals this plate. So here it takes in some plate, we're going to call it P, and I'm going to say, is P strictly equal to the plate in question? And I can go to the console here to give us an example of what that would look like. So let's see here. Ooh, okay, clear that. I'm going to make a string. I'm going to make a string array, in this case, a number array. 1, 2, 3, 2, 2. And I want to, on it, let's say I want to look for instances of 2. I want to say map, and I want to say, is it the case that P is 2? Right? I could use strictly array here as well, but either way. Yeah, and I see that all the ones that are true. Now, an interesting fact about JavaScript or many programming languages is when I try to sum Boolean values, trues are treated as 1s and falses are treated as 0s. So that means if I have, if I were to sum this up, you can imagine all of the 0s and all these as 1s, and I'm going to get a number back. And if that number is, 1, that means there was 1 instance in that was 2. If it was 0, there weren't any 2s. And if it was more than 1, that means there was at least 2 of them. So I can say here, let's say I wanted to reduce it, and I could have an accumulator and a current value, and I'm just going to sum them. That gave me 3 because there are 3 instances of 2 in this array. So here I map the plates, and here I have this array with the mapping, and then I want to reduce it by finding the sums. And that's the count of the plates in it. So here I'm going to say dot reduce the accumulator and the current value. Oh, and I have to put this in parentheses. I want it to return the accumulator plus the current value with a default value of 0. And I can clean this up just a little bit. There we go. And I want it to return this. So I can say return this, and it's going to tell me how many of this plate are in plates. So that's the count function. So now that we have count, I can just say find all of them that have a value that is greater than or equal to 2, and then keep it in the array. So I can filter our plates array based on this condition. So here I want to return plates.filter with the following. For each plate, if it is greater than or equal to 2, which means there's at least 2 of them in the array, then I can keep it. So on each plate, is it the case? So actually, I'll just say P because that's shorter and I don't want the line getting too long. P, if it is the case that the count of P is greater than or equal to 2. I'm not it. Yeah, that's right. If it's greater than or equal to 2, I want to keep it. All right. So now I can run this and I should see the array with 3, 4b, 3, 1, 7 shows up. The empty array shows up for here, and just the value 2 shows up on the last parade. So I run this. 2 strikes is not defined. Oh, that's right. Here we called it strikes. Let's just call this 2 strikes. And I run this. That is an interesting outcome. Oh, you know what it did? First off, I have to console log the results, so it's only showing the last one. Here, it's keeping all of them that have at least 2 or more of them. And I need to ensure that I only have 1 in there. So that's an interesting point here. So I'm finding all of them, but it's keeping the duplicates instead of just showing them. So first, let me console log this output so you can see what it's doing. Oh, yeah, I got the comments here. Put this at the end. It's going to close all of these. And close that. Beautiful. So you'll see that it actually keeps the duplicate. So here I have both of them. Here it has 3. So now I can run over our plates and say, I want to get rid of duplicates. And I can do that by checking if their count is in fact greater than 0. So I can say, for each one, check if its count is in fact greater. And if it is, I can remove it. And I could do that iteratively, or I could do that with a filter. Right, so here I could just say get the first instance, or I could loop over it. Let me just see here. Map, reduce to get the ones that are found to have duplicates. Filter if it's greater than or equal to 2. I forgot off the top of my head what built-in method would be the best way to do this. It's pretty trivial to do with a for loop though. So now I need to say is duplicate and then remove it. But if I remove it, it's going to remove all of them because they're all duplicates because it's looking at the array at that time. So I guess I could keep running it through 2 strikes and it will remove the re-instances. All right. I had this just a second ago. Where did I put it? Count greater than or equal to 2. I can filter it. Alternatively, instead of using the filter, I could just say, place it in if it's not already in the array. So here I can say I have let my result equal, well, an empty string. And I can say for plate of plates. Yeah, so I forgot what specific method to use in the filter approach. So let's just use a hybrid approach here. For plate of plates, I can say if the plate is not in res, so if, where res stands for results, not res.contains plate. So this will ensure we don't have any duplicates. Dot contains the plate. So if it doesn't contain the plate, then I can add it to the array if its count is greater than 0. So I also want to have a second condition here. And it is the case that the count of the plate is greater than or equal to 2. Then I can say res I want to add to it, so I can use concat. Res.push, sorry. I can push to the array. Oh, there we go. Res.push this plate. And after I've gone through it all, I can return that result. So now I run this. Res.contains. Oh, it includes, sorry. That's the name of the method. Run. And we get our expected output. Are there any questions to this solution? The alternate solution is, instead of segregating the logic into a separate function called count, I could have done that within another for loop that says, if I've already found it in this array, then I can put it in. So I can find all the ones in the existing array, and I have to keep a separate counter. Say, has this value been found? But we can redo count in a purely iterative way with a for loop. So I can say let I want to say count, but that's the name of the function. I'm just going to say counts equals 0. And I can say for plate of plates. I can say if, I can't say plate because I already used that here. So I can call this P for P of plates. No, not package. For P of plates, if P is strictly equal to, a little too strict, is strictly equal to our plate, then I can say I want to increment my counts. Then I can return my counts. And this should work exactly the same way. Yeah. So just like the map, I'm still having the same check to see if it's equal. And I'm incrementing on every condition where I found it. So now I can run. And it got the exact same result. All right. So that is the functional and the iterative solution to this problem. Although I did have to use a for loop at the end because I couldn't find the condition to filter if it does not already exist in our result. Are there any questions? No questions? All right, then I will move on to the next problem. All right, what's your grade? What's your grade? A control flow problem. Let me just erase the contents here. So this problem is to write a function that takes in a number parameter representing your GPA, and it represents the corresponding grade of that GPA. So if you have a 3.0 GPA, that means you're a B student. 4 is an A, 2 is a C, 1 is a D, and 0.9, or any number under 1 is an F. So if I was a 1.5, that would still be a D. If I was a 2.99, it's not quite a B. So that's technically a C+, but we're still going to categorize it as C. So here, ignore all the pluses and minuses to grades and only focus on A, B, C, D, and F grades. And anything between 1 and 2, not including 2, is going to be a D. Anything between and including 2, but not including 3, is going to be a C, and so on. Are there any questions to the specifications of this problem? No? Then I will send this in the chat. And we have 15 minutes to work on this problem. All right. So what's your grade? Let's copy these and make these our tests. All right. 1, 2, 3, 4. Be sure that we console log this. Great. So there's a very interesting thing is one thing is these are going in ascending order. F is 0, D is 1, C is 2, B is 3, and A is 4. Now, if we think of the keys of an array, those increase in exactly that order. So let's try and store these grades in an array in that order. So we have F, D, C, B, and A. And if I were to get the index of 4, 0, 1, 2, 3, 4, that would give me A. The index of 3 is B, the index of 2 is C, the index of 1 in this array is D, and 0 is F. But what about numbers that are greater than 0 and less than 1? We need to round those down to the nearest integer, so it might be indexed accordingly. So if I had a GPA of 1.5, that would go down to D, because it's not quite a C, even if it would be a, I don't even know if D plus is a legitimate grade or not, but yes, I'm pretty sure it is. So one thing I can do is I can return the grades, and it's not just going to be indexed to the GPA, because I have to bring that GPA down to its lowest integer, to the nearest integer. So I can use math.floor on the GPA, and that will bring it to the nearest one down, which will take me to the nearest index. So if I run this, they all pass. All right. I suppose you could alternatively make a dictionary saying, 0, 1, 0 is F, 1 is D, 2 is C. But making a dictionary where all the keys are indices, you're better off just making an array at that point. Are there any questions to this solution? No? All right. So moving on to the next problem. What's my GPA objects? Actually, now seems like a reasonable time for a break before we move on to that problem. So why don't we take 10 minutes and then we'll move on to the next problem. So I'm going to put 10 minutes on the clock and then we'll start our next problem. All right, so we need to write a function that takes in an array of letters represented by grades for a semester. A plus, C plus, B plus, all of these letter grades will be considered, and returns the cumulative GPA for the semester. So if you got all of these grades and each grade is equally weighted in your grade distribution, then this should be your final grade, because you're taking 4.33 for the A plus, you're taking the 2.33 for the C plus, this 3.33 for the B plus, so on for each of these, adding them all up, and then you divide it by the number of grades, and that is your GPA. That's the formula for cumulative GPA, and you are to implement that here. Are there any questions for this problem? No? All right, I will send you the link. And we have 15 minutes to work on this problem. I'll put that on the timer now. 1500. And I'll see you then. All right, I'm gonna copy these tests over. It'll let me, that is. All right. And we need to assert that these are, in fact, strictly equal. I need to console log my results so I can see them. Great. Oh, no, did not want to do that. Great. So before I find the cumulative GPA, I have to be able to find the actual GPA of an individual letter grade. So why don't I break that into its own little function? There are two ways I could really approach this. One is I could simply make an object mapping each letter grade to its corresponding GPA, but I have a simpler solution. Well, if we ignore all of the positives and negatives, just like our last problem, A is 4, B is 3, C is 2, and D is 1, and 0 is F. The only difference is that when there's a plus, I add 0.33 to that answer, and when there's a minus, I subtract 0.33. So first, let me make the function to say, get GPA, and it takes a grade in question and resolves its particular GPA. And it's going to be very similar. It's going to be kind of like the opposite of the last problem we did. So here I'm going to have a grades array of all the valid grades. And it's going to start with F because that's 0. So we have F, D, C, B, and A. So now I'm going to store my little result here for the GPA that I've resolved. And I'm going to say that is, instead of indexing at a math.floor, I need to find the index where this value is reached. So it's the opposite kind of response. And there's a built-in method in JavaScript called index of that finds the first instance in the array where that thing was found. So I could say, grades, if I can spell it, that is, grades dot index of, and where that grade is found. And that's going to return a number between 0, 1, 2, 3, and 4 inclusive, depending on where the first instance was found. But that's not the final answer. Additionally, this grade may not be A, B, C, D, or F, but the first letter in it is guaranteed to be one of those. So I can say get it at the index 0, because remember, grade is a string. Now I want to see if this grade string has more than one letter in it, more than one character in it, then I know it has a plus or a minus at the end. So then I know I have to subtract or add 0.33 respectively. So I can say if the grade.length is in fact greater than 1, now there's two things I could do. One is I could have an if statement here saying if the second value is a plus, then I want to add to my GPA. I've stored 0.33, else I want to subtract 0.33. But I have a different solution that I can do in one line. The value itself is the operator I wish to utilize. If it's a plus, I wish to add it. If it's a subtract, I wish to subtract it. So I can use a built-in method in JavaScript called eval, which allows me to evaluate a string and determine its result. And I can show you what that looks like here. If I want to evaluate a string 1 + 1, it will give me 2. So I can take in input as strings and evaluate operators within them. So I can utilize that here to make my code just a little bit cleaner. So now I want to say that I'm going to set my GPA equal to the evaluation of the current value of GPA, and the operator which you use, whether it's plus or minus, is going to be the grade's second value, which I know it has because the length is it has at least 2 characters in it. And then I want to add the amount, which is 0.33. Great. And then after all that is said and done, I still need to return that GPA. So this will get me the GPA of any particular grade, but I need to find the GPA of every single one of these grades, add them up together, and then divide it by the number of grades that I have. And that will give me the cumulative GPA for that semester. So I can go down here and I can say, I want to return the array of grades, and I want to perform a reduction on this, which means I want to do something where I operate on every single one of these. So I can say I want to reduce, which means I want to take all these values and return one single value. And it's going to take in our accumulator, which can be our cumulative GPA. So that's our CGPA. And it has a current value, which is just the grade in question. And it's going to do something with it. Actually, it might be easier if I put this on a second line, a little easier to read. All right. What I want to do is I want to take the cumulative GPA and I want to add to it actually, no, this is probably better. I just call this the sum, because the cumulative GPA is going to be divided by the length anyways. So I have the sum, and I want to add to it the get GPA of this grade. And after all of that is said and done, I want to divide it by the length of array of grades. Array of grades dot length. All right, so now let's check to make sure our answers are correct. Ooh, they're not. Why is that? Let's take a look at our outputs. Not a number. Let's see here. One thing I'd like to do, this is a good opportunity to debug our problem. Let's console log the result of get GPA if I were to apply get GPA to each of the grades in my GPA. So let's console.log. Array of grades dot map. And I wish to apply the following function to each one, and that's going to be get GPA. Great, and I'm going to run this. Yeah, and it is giving me the correct ones. A plus is 4.33, C plus is 2.33, B is 3.33, A minus is 3.67, C is 2. So we're getting the correct values for each grade. So I know that this function is correct. So there's something wrong with my logic here. Here I have this. Oh, you know what's interesting? Did I close this correctly, first of all? Yes. Did I provide the initial value? No, I did not. That should be 0. So now I run. Yep, there we go. Now the first result is 3.132, and the last is 2.866, which is exactly what it should be. 3.132 and 2.866 respectively. Are there any questions to this particular solution? Nope. All right, let's see if we can squeeze in our solution with a for loop this time. So this get GPA function, we can still use this in our iterative approach. But instead of using a mapping or a reduction, what I'm going to use is a for loop. And I'm going to say for grade of grades. So I go over all the grades. And just like before with our reduction, I still need to keep a sum. So I'm just going to say let sum equal 0. I have my grade of grades. And I'm going to say I want to add to the sum the get GPA of that grade. And then after all that's done, I need to return the sum divided by the length. So return sum divided by array of grades dot length. So I can run this. Ooh, grades is not defined. Oh, my bad. It's called array of grades. Yes. Array of grades. So I run, and I get the correct results. Wonderful. Another thing that I did here that may be new to you is instead of using this evaluation, I could have branched with if and else. So I can say if grade 1 equals plus, then GPA plus equals 0.33, else subtract 0.33. And the third solution would have been for this get GPA function to just have an object that had all of these values you see in this table here and mapped each letter grade to its respective GPA. And then that would have been the return value of this function. So those are the different approaches to this problem. Are there any questions? No? All right. So if that's the case, then we are done for today. Oh, there's a question here in the chat. In the interest of best practice, is it better to pursue a loop or inline methods? That's actually a pretty interesting question. A lot of people will agree and disagree as to the benefit of inline methods. There's a very vocal community amongst programmers that inline methods are generally better optimized. And that really depends on what the method is doing behind the scenes. When I make the for loop, I know exactly what's happening. But when I make the method, it might be doing something differently behind the scenes. And that might be faster, but that depends on the language, that depends on the compiler, it depends on a lot of other stuff that's kind of beyond the scope of this course and determining efficiency. So I personally like inline methods as long as I still find it readable. There isn't one solution. Sometimes for loops are easier to read. For the challenges, what would you recommend? I actually don't have, I'm really just saying pick whatever is more comfortable for you. I think most people are going to be more comfortable working with for loops. And I think you're probably going to find there's less of a learning curve to working with simple loops as opposed to learning all of these different methods. So I would recommend you work with the loops if you had to pick one, just because it'll probably be a lot easier for you to do. But knowing the methods is important. At the very least, you understand other people's code. So do familiarize yourself with them. All right. All right. So this is our last one for this week. I will be seeing you on Monday next week for the 7th session, if I'm not mistaken. Yes, 7th. All right. See you then.